Hello, friends. So recently, when I was reading blog posts by Rasa, I came across this paper by Apple called Leveraging User Engagement Signal for Entity Labeling in Virtual Assistant. And I find it quite interesting because it's directly related to a business problem and it's a problem that Apple was facing and they've written a paper for. So when we talk to virtual assistants like Siri, in the background first day you have to translate the speech to text and then from the text extract entities from it. And the challenges Apple faced is that in speech recognition, the speech can be noisy, business requests can be ambiguous or brief. For example, in the paper, it points out this example, play that song, train. And play is the intent, play that song is the song name, and train is the artist name. Now, even for humans, without domain knowledge, it will be hard to label these entities. So what Apple came up with is they use multitask learning. So they have a coarse-grained entity label. For example, the music entity. So this example here will be a music entity that can be easily labeled. Whereas the more fine-grained entities like the music artist, music title, which is more time-consuming, they use a different metrics to do that. So the idea is that for fine-grained entities, let's say if the user stayed listening to that song for more than 30 seconds, then we automatically label the virtual assistant has made the correct inference. Else, if the user did something else, for example, switch a different song or manually entered a different song, then we consider that's an incorrectly inferred label. So in addition to that, Apple also use knowledge base to validate their inference. And how do they go about doing that? They do that by using a bidirectional LSTM with a multitask learning. So in the architecture here, we can see, for example, Play 1 by Metallica. So these will be some embeddings. It first feed into a bidirectional LSTM. And now those two vectors are concatenated into one vector and then sent to an output layer. The difference is we don't just send it to both of the output layers for the coarse grain and fine grained. So if the mini batch fed in is labeled by the supervised learning coarse grain entity, then the weights for the output layer for the coarse grain will be updated, whereas the weights for the fine grain will be frozen, vice versa. So if we fed in a fine grain label, wiki supervised label, then the gradient will only be upgraded for the fine grained output layer, not the coarse grain output layer. However, the weights for these ones are both shared for regardless of the mini batch, whether it's a coarse grained or fine grained. So coarse grained, once again, is kind of easier labeled data, for example, the music entity. The fine grained is more detailed, for example, the music artist, the music title, etc. Now, in terms of the loss function, the ground truth for the coarse grained label is added by the loss of the fine grained labels and then also added a regularization term here, which make up the final loss. So as mentioned before, Apple also take an extra step by using a knowledge base to validate their inference. So let's say if we made an inference about a song about Beatles, then it will check the knowledge database whether that song exists or not, that relation exists or not. If it exists, then it upranks the inference. Otherwise, it will downrank it. So in terms of the result, Apple finds that using weakly supervised user engagement signals, like for example, did the user listen for more than 30 seconds into the song? Then there's a positive label, otherwise there's a negative label. So comparing like a human annotated 5K examples of coarse-grained versus 10K, if we have got with the fine-grained entity labels, so here we've got the fine-grained entity labels, the error rate achieved was even lower than baseline one without the fine-grained user engagement signal. So yeah, I found this paper quite useful and interesting because for example, new domains where we may not have fine-grained entities, and those entities may be very time-consuming to label, we can use other metrics to do weakly supervised learning, combining with other supervised labels. And I particularly like these sort of papers because it's directly related to a business problem. So if you're interested, feel free to check it out as well. I'll put the link in the description.